Okay, in this video we're going to be setting up the app and getting your app ready to go. Basically, to deploy an app, most apps, you need an environment, and then you need the ability to pull images from somewhere. So what we're going to do is we have an env.properties file. This env.properties file has a format of like database URL equals, just to show a random example, this type format. And the reason this is important is because we're going to leverage that to essentially load in our credentials on the fly here. So once you've got your config, and if you're coming from another environment like Heroku or something like that, you can basically just pull all that down and edit it, put it in your config map, and then you can leverage this command to push that config into Kubernetes. Should all this be secret? Should it be encrypted? Absolutely, but net, I'm trying to get an app up and running. I'm not worried about trying to base 64 encode, decode secrets, and anyone who has access enough to the Kubernetes cluster in order to be able to see it probably has enough credentials to do something bad anyway. So I've opted for a simpler approach. The other plus of this is that I can then run, edit the config map here, and when I do that, it's going to launch in VS Code. I can make a change to my environment and then save it and handle it all that way. So it's much simpler to manage versus having these in secrets that are really not secrets because they're just base 64 encoded anyway. And so that's just the way that I've done it. So then the other thing that we need is we need to be able to log into Docker Hub, or wherever your images are stored. This is the command I used, basically with a Docker username and a Docker password, and obviously put in your real Docker username and password here and your email. But it'll have the name regcred, which we'll see in a minute, and that basically gives you the ability to pull the images using private images from Docker Hub, so you're not having to publish everything in public. And so next we're going to deploy, and what we'll be deploying with is this app.yaml file. So this YAML file has a number of different parts in it. It has the service component, which defines the service. It has the deployment component, which defines the actual image, and then it has an ingress route that essentially says, hey, traffic, route traffic that's asking for this host name to this address. And that is what's here. So let's talk about the deployment first. This is a pretty straightforward process. There's not a lot of complexity in here. The one thing that we'll talk about later is using Keel to auto deploy. So basically when you push to master, it will build an image. Once it builds an image, it'll create a new Docker image, and once that new Docker image is created, it will then send a webhook to Keel. Keel will redeploy a rolling update to a new version of the application, and all that'll happen on the fly. So that's what this Keel annotation is. Important things: namespace and the name of the app, the name of this process. The default number of replicas, you can obviously change this to whatever is appropriate for your environment. Your image pull secrets, this is the registry credentials, the Docker credentials we just talked about. Your environment is from the app config, and this is what we put in previously. I know it's not best practice to use latest versus using snapshot. I just haven't made that change yet, but there's a way to do this. in the system, but that will get it up and running. I'll show you this in a bit within our app, but basically we're using Tiny, which is a little kind of a environmental shell piece, and then our entry point points at a particular thing that will launch this out, right? So that's how we're managing these various commands. So the worker image just points to a different production worker instead of production server, and that's really the only difference. In terms of best practices, you do want to set resources. These are the ones we're using. We're kind of memory heavy, and it is what it is. So we use 1.8 gig essentially for memory, and then essentially one CPU. Map to port 5000, and then we just do our readiness probe. Just essentially checks to see if we can access the home page. The ingress route, these all look identical. So this is the name of the service that you're trying to reach. And you generally these things align because you'll have multiple routes. So anything that's routing to this service should be in this ingress route. And in this case, I've got app.bizbridge and then the Audiente app, both routing to that same service. And then all of these are using the BizBridge TLS secret with Cloudflare that we talked about before, and that skips the need to do any of that Let's Encrypt junk that goes along with it. So, and then lastly, and these aren't in necessarily any order, but here's the service. So this is the service that's essentially taking this deployment and it's creating a handle that we can use to reach it from the ingress route. So, and then per here, you just basically you make those little edits and then you go and deploy, and I'm deploying into the default namespace, the app. And I've deployed the app, and then I've also deployed the worker leveraging the same thing. And so what you can do is you make sure you're in the default namespace, and then you get the pods, and you should see pods. And then from there, you can do logs on the pods and make sure that you see the app has come up and it's showing that it's set to go. So you can, I call this out, sometimes you need to do this. So say traffic isn't working for some reason, you can't see things from here, and you need to be able to access the port. You can do this port forward. Basically, it'll map port 5000 to port 8001 on your local, and you can then access that pod just like you can through traffic. And that's to make sure that you understand whether the problem is in traffic or whether the problem is in your own pod. And then if you've done all that correctly, at this point you should be able to access whatever you mapped it to, and you should be able to get access to the front end of your app. As I said, workers are virtually identical. They're configured the same way. The only difference here, as I mentioned, is I have it pointing at a different command to start. We're asking for more memory because of the way our app works. And then we have a liveness probe set up for Sidekick using Sidekick Mon to make sure that it's up and running. And then the other thing that we have is, and this is Rails specific, obviously, for the lifecycle pre-stop, we execute this Sidekick quiet. And what that does essentially is tell Sidekick to stop taking new jobs and to complete the jobs that it needs to complete. And so that's the gist of deploying the worker, and you deploy the worker the same way that you deployed the app itself with this, but you would essentially change to worker.yaml, right, versus app.yaml. And that could be web, that could be whatever, the names don't matter. So that is deploying the app. Pretty straightforward. And at this point, barring complications or differences, you should have the app up and running at this point. So the next thing we'll talk about is now how do you deploy new versions of the app, and we'll cover that in Keel and all of that next.